Hey YouTube, it's Wasim, and today I'll be showing you how to script an open and close door on Roblox. Now this is my first scripting tutorial, so take it easy on me. But yeah, so there's many ways people have gone about making a door on Roblox. I've seen people use C-frame lerp to get a door rotating by its edge, which is pretty mathy. Um, I've seen people use constraints with body movers. That's another way of doing it. But in this tutorial, I'll be specifically talking about how to get this going using tweens, right? So let me go ahead and show you what the end result will look like. You can see here we have our button. If I click on it, the door opens. If I click on it again, the door closes. Now what if I try to close it midway? Right, you can see that it behaves as you'd expect, right? So if I was opening it and I click on it again, it'll be able to close midway, right? So that's a cool thing about this door. So now this door model is composed of many various parts. You have the C-frame value, you have the button, the door, and then the hinge, right? So now this hinge is of special importance because whenever we go ahead to rotate this model, we want to rotate the model relative to the hinge or about the hinge, right? So that's why I went ahead and made the hinge the primary part of this model, because when we rotate it, you'll see that the door, the hinge is anchored and the rest of the door is rotating relative to the hinge. And it'll make more sense once we start scripting in a second here. So I'm going to go ahead and delete everything inside the script, and we're going to start from scratch. So the very first thing you want to do is put a click detector inside this button, right? That's what will allow us to detect mouse clicks on the button. So the very first thing I'm going to do is I'm going to reference that click detector. And we'll also need to reference the tween surface because we'll be tweening this door. Right. Also, it'll be useful for us to reference the door model. Also, it'll be useful to define a variable called total time. Now, this total time variable will determine how long in total it should take to completely open the door or completely close the door. I'll also define a variable called isOpen, which will determine the current state of the door, whether it's opening or whether it's closing, right? I'm also going to hook up a function to the mouse click event, right? So that when they click on the button, it fires this function. All right, so now this C-frame value, I never explained what the purpose of it was, but I'm going to go ahead and explain that, right? So to do that, let's go to the tween service documentation. So if we go here, it says tweens are used to interpolate the properties of instances. These can be used to create animations for various Roblox objects. Now, so as it clearly states, tweens are used to interpolate the properties of instances, right? So now, what we're trying to do is we're trying to get this model rotating. Now, the model is an instance, but it doesn't have any particular property on it, as you can see here, that we can tween, right? So because of that, I create a separate C-frame value, which is an instance, and the C-frame value instance has a value property, right? And using that, we can tween between two different C-frame rotations, right? So the C-frame value is sort of like a crutch because the model instance doesn't have a C-frame property on it that we can tween. So we use a C-frame value instance rather to get the to tween the rotations, right? C-frames. So I'm going to go ahead and reference that here. I'm going to call it CF value. It's going to be equal to door dot C-frame value. Right. Now I'm also going to say CF value dot value is equal to door dot primary part dot C-frame, right? So I'm setting the initial rotation, the initial C-frame of the C-frame value to be equal to the initial C-frame of the hinge, right? And the initial C-frame of the hinge is just like what it looks like right now. It's not rotated at all, right? So that's what I'm doing here, right? It might even be useful to define a variable called hinge and set that equal to door that primary part, right? Just because it makes more sense. And set the CF value to initially be hinge.cFrame, right? So now let's deal with the condition where the door is not yet open, right? So it's in a closed state right now. So to tween any property, you need to set what's called a goal state, right? Now the goal state is what we want the end of the tween to look like, right? So in this specific case, the goal state would be the rotation of the door when it's completely open, right? So the door right now is not currently open, but we want to set the goal state of the animation to when it's completely open. And what tween service will do is it'll take the current rotation of the door and then it'll rotate it all the way until the door is completely open, right? So to do so, we need to create a goal variable, right? And if you look at the tween service docs, right, you can see that here, they're tweening position and color in this case, and then they set a goal position, right? So the parse position is initially this, right? And then, from what it looks like, they're tweening it so that the parse position moves right, 10 units. So that's what we're going to do here. All right, cool. So now when the door is not open, right? I'm going to say goal that value, right? And also I want you to notice one more thing about this is that I guess you could say the members of this goal table correspond with the properties we want to tween, right? So if you want to tween the position property, you'll say goal.position and then specify the goal position. If you're tweening color, you say goal.color, specify the goal color, right? So in our case, where we want to tween the value property on the C-frame value, right? And I can't see the value property here because it's hidden. Roblox hides it for some reason. But note that the C-frame value does have a value property, right? So we want to tween the value property. So that's why we say goal.value, right? So we're going to say goal.value is equal to C-frame.new. And I'll explain what I'm about to type here in a second. So what does this mean, right? So I want you to notice that if we're rotating this door, right? Now I want you to think about this hinge. Just focus specifically on this hinge. This hinge's position will never change, right? The hinge's position never changes when we rotate this door, but its rotation does, right? So when I say C-frame.new CF value.value.p, I'm creating a new C-frame that has the position of the hinge, right? But without a rotation component, right? Because a C-frame has a position and a rotation component, right? So I'm creating a new C-frame with just the position component, but without the rotation component, right? And then I multiply it by C-frame.angles, and and this stuff right here, right? So what does this mean, right? So because we're rotating the door, if you think about it, we want to rotate the door about the y-axis, right? So if you imagine a line coming from the sky and then into the ground, right? We want to rotate the door about that line, right? We don't want to rotate it about the x-axis. We don't want to rotate it about the z-axis. So that's why I say 0 there. We want to rotate it 90 degrees about the y-axis, right? And this math.rad is just a function that converts from degrees to radians, right? Because C-frame.angles accepts radians, right? So we convert 90 degrees to radians, which for all of you trig people, that's math.pi divided by 2, right? You could, write that in substitution of this, but I'll just leave it as math.rad 90, right? Right. So because we've now set the goal state, we want to set is open equal to true, right? Because the door is no longer closed anymore, it's going to start opening, right? So I'm going to create an else, right? So the else condition is for when the door is closed, right? So if the door is closed and then we click the button, right, we want it to go back to where it was initially, right, which is completely closed. So we're going to say goal.value, it's almost the same thing. But this time, instead of saying math.rad 90, you're going to say math.rad 0. Now, right, so instead of rotating the door 90 degrees, right, if the door is already completely open, right, we're going to set the goal state to be completely closed, right, which is just 0 degrees, right? Now, since 0 in radians is also 0 in degrees, you don't have to do this conversion. You could just say 0, but just for my eyes, I'll just leave it as math.rad 0. Honestly, it doesn't matter. You don't need to do that. You can just leave it at 0, right? So if the door was closed, right, then we're going to say is open equal to false, because after we set the goal, now it's going to start opening, right? I mean, if the door was open, we're going to say is open equal to false, because now the door is going to start closing, right? Sorry about that, right? So this is for when the door is closed, right? And then once we set the goal value here, we're going to set is open equal to true, because the door will start opening. Now this is for when the door is completely closed, completely open. So we're going to set is open equal to false, because it's going to start closing, right? Makes sense? So don't get confused between those two things. Okay. All right, cool. So now what's next, right? So next thing we need to do is we need to create this tween info, right? So now this tween info determines how long it should take for the tween to complete, right? So now you could, this tween info also has other parameters, right? But I'm not going to focus on those for now. They'll be relevant later in this video. But for now, let's just say it takes 2 seconds, right? Now there's something very wrong with setting an absolute value for this, but I'll just leave it as, actually let's say total time, because that's what we intended, right? Total time. Now there's something wrong with this, but later in the video I'll come back to it and tell you exactly what's wrong with doing things this way. Alright, cool. So then we're also going to go ahead and then we're going to say local tween hosting service create, right? So the first parameter of create is the instance for tweening, right? Now the instance for tweening is just CF value, right? We're tweening the C frame value instance, right? And then the second parameter is the tween info, right, which we just created. And then the third parameter is the goal, right? And we're just going to pass in that goal table. Cool. And then the next thing we do is we play the tween, right? So this will start playing the tween, right? So this is cool and all, but we actually haven't done anything. The tween is playing, right? So if we were to run this, the tween will be playing, but our door won't actually be moving. So if I go ahead and play this, I'm going to view the output so that you can see any errors. There is any. So if we play this, you can see we get no errors, right? But the door is now opening. Why is that, right? So the truth is the value property, because if you remember, it's the value property on the C frame value that we're actually tweening, right? We didn't change anything about the orientation of this door. All that was changing was the value property of the C frame value, right? So now we have to somehow, set the, rotation of the door as the C frame value is continuously being tweened, right? So here's how we're going to do that. I'm going to say while wait, then do, right? What we're going to say is we're going to say door set primary part C frame CF value dot value, right? Now let's go to the documentation for set primary part C frame. Right. So if you go to the documentation, here's what it has to say. It says the C frame of the model that primary part. All other parts in the model will also be moved and will maintain their orientation and offset respective to the model that primary part, right? So in our case, model that primary part is the hinge, right? So it's saying that all other parts in our door, right, will maintain their relative orientation relative to the hinge, right? So such that whenever we rotate, when we call this subprimary part C frame, whenever it changes the C frame of the hinge, it's also going to move the rest of the model along with it, right? So it's going to move the rest of the door along with it, right? So that's what we're doing here, right? And now this while loop gets called 30 frames per second, right? Because if you call wait without passing any arguments, by default it's just going to wait 0.03 milliseconds, which is 30 frames per second, right? So every 0.03 milliseconds, or not milliseconds, sorry, 0.03 seconds, right? So every 0.03 seconds is going to be updating the door with the C frame value that we're tweening, right? So it's going to set the C frame of the primary part, right, to the value property on our C frame value, every 0.03 seconds or 30 frames per second, right? And 30 frames per second is good. It's going to look smooth. If you want it even smoother, you could use the Roblox heartbeat functions and stuff like that if you want it faster than that. But for things like this, 30 frames per second is enough. You don't need you won't see much of a difference, honestly, if you try to go higher than that, right? So that's what we're doing here, right? But so there's still something wrong with this. Just putting a while loop here, it's cool, but there's still something that's very wrong with it, right? So I'm going to go ahead and play this so that you can see. Right. It looks like it works, right? And it does work, right? But there's something very inefficient about this while loop, right? Because once the C-frame value is done tweening, right, then we're still looping and setting the door C-frame even though the tween has already ended, right? So the door could be completely closed, right? And then we'll still be, looping and updating the door C-frame, even though it'll just end up in the same position, right? So once the tween has ended, it's still updating the door's position constantly, and it's just updating it to the same thing, right? So we want to detect when the tween is done so that we can stop updating the door's position. So this is how we do that. Every tween has a completed event, which basically determines when the tween is completed. And we're going to hook that up to this function, right? So what I'm going to do is I'm going to create a variable at the top called isTweenDone. And this will determine whether or not the tween is done. And so once the tween is complete, I'm going to set that variable to be equal to true, right? Such that I will only, and now I'm going to say while not isTweenDone and wait, right? So the cool thing about this is now this while loop will only run as long as tween is not done. But once it's done, it's going to exit that while loop so that we're not, wasting our time, with infinite loops that never stop, right? All right. So, visually, you're not going to see any difference when I run it now. It still behaves the same. Right. Okay, so now I want you to notice another thing. Right. You see how if I try to click it midway, it still takes 2 seconds for it to get back to this initial state? It's like it's slowing down, right? Maybe this will be more pronounced if I extend total time. Let me set it to 3. You see that? It slows down. So why is it slowing down, right? So the reason it's slowing down has to do with this tween info parameter, which we're passing as total time, right? So when we pass total time to this, it's saying, hey, we want the tween to take 3 seconds, no matter where it is. Now, 3 seconds is good if the the tween is, if the door is completely closed or completely open, right? It makes sense that it'll take 3 seconds for it to completely close or completely open. But if we're currently in between the tween, or like the door is like midway, right? It's not completely closed, or it's not completely open yet, right? And we click on the button, right? We don't want it to take 3 seconds from where it is, wherever it is currently, to become completely open or completely closed, right? So we have to change how much time it takes for the tween to we have to change how much time it takes for the tween to complete, right? Based on um, the difference in angles between where the door is currently and where we want to get to, right? So for example, we're going to pull up, Microsoft Paint. Let's say that this is the completely open state of the door. And let's say that this is the completely closed state of the door, right? If we're going from here, closed, all the way to open, right? That's a 90-degree difference, right? Then it makes sense that we want that to take 3 seconds, right? But let's say that the door is currently at 45 degrees and we choose to click the button, right? Then it doesn't make sense for it to take 3 seconds to go from here to here, right? Or from here to here, right? But rather, if the door is at 45 degrees, we want it to take half of 3 seconds to get to its goal, whether it's completely open or completely closed, right? So instead, if it's at 45 degrees, we want it to take 1.5 seconds to tween, right? And 1.5 seconds is 3 divided by 2. Because 45 degrees is halfway, we want it to take half the time it takes to, go 90 degrees, right? So the way we do that is using a simple mathematical ratio, right? So if we know that, let's say that, if we know that 90 degrees takes 3 seconds, right? Then we want 45 degrees. The 45, so this is the ratio, right? 3 over 90, right? So that means if you multiply 90 degrees to this ratio, we'll get 3 seconds, right? But if you multiply by 45 degrees, we'll get half of 3, which is 1.5, right? So that's what we want to achieve, right? So using that ratio, we can determine how long it should take to tween from whatever the current rotation of the door is. But to do that, I have to first figure out what the difference, right, from where the door is currently to where we want to go, the goal, right? So I have to determine that this is actually 45, right? It's not always going to be 45. It may be like, 10 degrees, right? And then I would have to determine the angle here, right? So that's what we're about to do. So to determine the angle, there is a useful C-frame method. Right. So what we're looking for is, what we're really interested in is we're interested in the difference in the rotation about the y-axis, right? Not any other axis, just the y-axis, right? So I'm going to use this method, two Euler angles, x, y, z. going to say C frame. Let me put it down. Yeah, let me put it right there. C frame to Euler. But we have to specify what C frame it is, right? So the C frame is going to be the difference between the current C frame, right, and the goal, right? So it's going to be CF value dot value times goal dot value inverse, right? So what does that mean, right? So you can think about when you call inverse on the C frame, think about it as kind of like negating it, right? Think about the multiplication as like adding a C frame, right? So if the goal, right, was completely closed, then goal dot value would be 0 degrees, right? But if the goal was to be completely open, then goal dot value would be 90 degrees, right? So we're taking the current value and we're basically subtracting it. Think about, like, let's say the current value was 45, right? Then this would be like saying 45 plus negative 90, right? Which will give us, negative 45, right? So it's like, adding to a negative number, right? That's how I like to think about inverses. So if that makes sense. Two Euler angles, X, Y, Z. Right? And so this returns a C frame, and off of that C frame, we're calling two Euler angles, X, Y, Z, right? So now I want to store the result of that. So two Euler angles, X, Y, Z returns three numbers, the X, Y, and the Z, right? So in our case, that would be the difference in the X, the difference in the Y, and the difference in the Z. But since, if you remember, we're just rotating the door about the Y-axis, we're just interested in the difference in rotation about the Y-axis. So I'm going to put underscore here, I'm going to put Y, then underscore, right? I put underscores there because I'm not interested in those values. I'm just interested in the Y, right? So using that that difference now, I can then, so we've calculated the difference in the angle, right, between the current state and the goal. So using that difference, I can then multiply it with that ratio that I devised earlier, right, which is, 3 over 90, or in our case, total time, right, over 90, right? And we really want to say math that absolute, right, because Y could be negative, but it doesn't matter to us whether the difference in the angle is negative or positive, right? It should still take the same amount of time, right? We don't want to end up with a negative time, so that's why I make it, I take the absolute value of Y to make it positive. So that's the adjusted version of this. So now if we run it, oh, very fast. So now why is it snapping like that? We must have missed something here. All right, we need to convert Y to degrees, right? Because two other angles will return radian numbers, right? It's going to return them in the radians. So we have to convert them to degrees when we're doing this multiplication because we're expecting degrees. right? So you can see here, if I do the full thing, it takes 3 seconds. If I'm at 45 degrees, it takes half of that, right? I also want you to notice one more thing, right? Is the fact that because of how, tween easing styles work, notice how when we click it, it starts very fast, slows down, right? Always starts fast and then slows down, right? But the timing is right, but it's just how the animation is interpolating, right? It's starting out very fast and then slowing down, right? So now you can change that, right? Because so the way you can change that is by looking at the parameters of tween info. So the first parameter, as we just saw, of tween info was the amount of time it should take to tween. The second parameter is what we call the easing style, right? So the easing style determines, how it interpolates, right? So if you say easing style dot quad, like by default it's easing style dot quad. So right now we're doing easing style dot quad. So as I just showed you, it starts off fast and then it slows down, right? Now there's also easing style dot linear, right, which will make it so that it's consistent throughout the same speed throughout the whole tween or animation, right? So I could say here, where's tween info, right? So I could say comma enum dot easing style dot linear, right? So then if I go to play it, you can see that the speed doesn't change, right? So now, that's just a preference thing. I honestly like the default with quad, right? But there's many other easing styles, right? There's easing style dot circular, so on and so forth, right? So you can experiment with this to what you like. But yeah, that'll be it for the first tutorial. I'm looking to make more tutorials in the future. So I guess stay tuned in the comments below. You can give some critiques about how I did. If you want to, like whatever suggestions you guys have, I'm open to it. Just put it down in the comments. Thank you, and that'll be all.